Hi, this is Carol. In this video series, we will go through some very basic skills of Quantlib. For the upcoming videos, I assume that you have the analytical knowledge for financial asset pricing, especially using Black-Scholes and Monte Carlo methods for option pricing. I will go through the basic steps of those models before writing codes each time, but it will not be in any details, so it's better if you already understand it. In addition, you will need to have some basic understanding of C++, but don't worry, you don't need to be an expert on programming. I myself come from economics and finance background, not programming. All the code that we do in this video, I will tell you how to construct them based almost purely on information you can find on Quantlib. Please refer to Felix's video on how you can download and get ready Visual Studio C++, Boost, and Quantlib on your laptop. The video is very helpful and it will take around 1 to 2 hours for the installation. You may return after that. For option pricing, or more broadly speaking, for the pricing of any instrument, we will have the following building blocks. First is the instrument itself. In this video, we refer to the option. We will need to construct the option in C++. Second is about the underlying asset of the derivative instrument, how you would like to describe statistically the price movement of the underlying asset. The third part is the model or the method you use for the pricing. For example, we can use the analytical method like Black-Scholes or the simulation method like Monte Carlo for the pricing of an option. Both of these two methods will be covered later in this video. When we talk about option pricing, we usually think of 6 parameters: the stock price, the strike price, the volatility of the stock price, the tenure of the option, the risk-free rate, and the dividend rate. Indeed, in the most common pricing methods that we use, for example, the Black-Scholes, those are all the parameters that we need. However, we must also distinguish the characteristics of the derivative instrument from that of the underlying asset or the pricing method that we use. Now let's recall the definition of an option. Here is the definition from Wikipedia. In finance, an option is a contract which gives the buyer the right, but not the obligation, to buy or sell an underlying asset or instrument at a specified strike price on or before a specified date, depending on the form of the option. So we have 4 characteristics of the option. That is the option type, whether this is a call or a put, the strike price of K, and the maturity date of T. We will also be concerned about the exercise type, whether this is European option, American option, or Bermudan option. So here are the constructors of an option. It has the 4 characteristics that we just talked about. And now we will try to build up this option in C++. So now let's go to the Quantlib website. You can open your web browser and search Quantlib on Google. And we go to Documentations and Reference Menu. And we will go to Classes. You can search option here, or you can just open this and find options alphabetically. Because option is the keyword for many other classes. And after we enter into the option class reference, we'll open the inheritance diagram. Quantlib has many options in it, and we will try to go down this inheritance diagram and find the one kind of option that is most suitable to our need. So we will first go to the one asset option. And under one asset option, we'll be using vanilla option. And under vanilla option, we have only one choice left, that is the European option, and it's just what we need. So European option is at the end of the inheritance diagram, and I suggest that you copy and paste its constructor to your Word file so that you can refer to it later. The good thing about Quantlib is that if there is something you don't understand, you can just click on it. So here we have the strike type payoff, let's go to see what it is. So this is a payoff function that will determine the amount that you will receive on the exercise date. So we will be using plain vanilla payoff. And it is at the end of the inheritance diagram. So we will copy and paste its constructors to our Word file again. And we can see that there are two parameters for plain vanilla payoff. The first is the option type, that is call or put option. And the second is the strike price, that is a real type. So we will go back and to see the exercise. We will click on exercise, and it has several kinds of exercise. We'll be using the European exercise. And European exercise has only one parameter, that is the date. So for European option, I only need to know the maturity date. Only on that day I can exercise my option. So we have everything ready for the construction of our option now. And now let's go to Visual Studio C++. I will build up the new project step by step this time to give you a demo. So we'll name it BSM Option Pricing. And we'll be using the empty project. Now that the project is ready, we will add a new C++ file. And again, we will name it BSM Option Pricing. Before we do the coding, we will first need to tell the processor where to find your include path and your library. So for include path, we will add the boost and the Quantlib. And the library will also include the boost library and the Quantlib library. Now let's start to write the program. To save you some time, I will copy and paste some part. So this is just to disable some warnings, and we will include the Quantlib head file here. And we'll be using the namespace of Quantlib. So if you want to use something from Boost or the standard namespace, you will have to specify that. So let's go to the Word file that we prepared earlier. And first, there is the plain vanilla payoff. So for this payoff, we have two parameters, the option type and the strike price. So we'll be writing the option type. Be careful here because C++ is case sensitive. So we will name it type. This is your own variable, so you can name it whatever you like, type 1, 2, 3. And it is a call option. And the second is the strike price, that is of the real type. So we will name it K, that is 25. So now the plain vanilla payoff is ready. We'll go to the definition of the parameter of the exercise. So it has only one parameter, that is the date. We'll be using date T, that is 26 March of 2012. So we have the three variables ready. We'll begin to construct the plain vanilla payoff and the exercise. So we'll be using the third pointer from Boost. And it is strike type payoff. We'll name it payoff. Again, this is your own variable. You can name it whatever you like. So we will use the payoff for the clearance. It has two arguments, type and strike price K. The second is just the same. So for exercise, we will again be using the share pointer of exercise. We'll name it exercise. And it has only one parameter, that is the time t. So both the share type payoff and the exercise is ready. Now we can begin to construct our option. So we have a European option. We will name it option. And it has two arguments, payoff and exercise. So now it's all done. We have the option ready. In the next video, we will be talking about how you can characterize the underlying asset and how you can call the right pricing engine.